Hello everyone. This is our next example for superposition theorem. In this circuit there are two nodes, or you can say there are three meshes. And in this circuit find current in each 3 ohm resistor, that is current in AB and CD branches, by using superposition theorem. And in this circuit, if you see, there is a possibility of source transformation, but we cannot apply source transformation because we have to find current in this 3 ohm resistor. If you have to find current in 2 ohm resistor or 1 ohm resistor, then you can apply source transformation for the circuit solution. So we will take this circuit as it is, and let's see the solution. For the solution of this circuit, we will take one source at a time and other sources replaced by their internal resistances, then take the algebraic sum of each energy source response. So let's see the solution. For the solution of this circuit, first we define currents in branches AB and CD. So we will assume the branch current of AB is I and the branch current CD is I dash, which we will calculate. So let's see the solution by each source. First we take 5-volt source. So for the 5-volt voltage source, current source will be replaced by their internal resistance, and the circuit will be like this. This is our resistances in the circuit. This is 3 ohm, 2 ohm, 1 ohm, 5 volt, 3 ohm, and our branches are AB and CD. There is only single source, so we can say it will provide a current I1, which is divided in two paths, and its currents are I2 and I3. We can easily find these current I2 and I3 by current divider rule. So for the current divider rule, we will make the equivalent circuit for total currents. So if you see this circuit, there is two branches, 3 plus 2 in series, and which is parallel with 3 ohm. So you can make the circuit by combination. This is 5-volt source, this is 1 ohm resistor. You can replace this like this, that is 3 plus 2, 5 in parallel with 3 ohm. So the equivalent resistance for 5-volt battery is 5 in parallel with 3 plus 1, or you can say 5 into 3 divided by 5 plus 3 plus 1. So the equivalent resistance for 5 volt, 15 by 8 plus 1, and the calculated value of this is 23 by 8 ohm. Now let's see the value of total current I1. So this I1 is 5 divided by 23 by 8, or you can say this is 40 by 23 ampere. So this is our I1. I1 is 40 by 23. Now calculate other branches current I2 and I3 by current divider rule, because we have to find current in AB and CD. So the value of I2, this I2 current is total current I1 multiplied by opposite branch resistance, that is 3 ohm, divided by total branch resistance. I1 into opposite branch resistance 3 ohm divided by total branch resistance, that is 3 plus 5. So its value is 40 by 23 into 3 by 8, that is 15 by 23 ampere. This is our value of I2. So now calculate I3. I3 is total current multiplied by opposite branch resistance, that is 5 ohm, divided by 3 plus 5, that is 40 by 23 into 5 by 8, that is 25 by 23 ampere. So this is the total current by 5 volt voltage source. So the 5 volt voltage source will provide current in AB branch. I2 is 15 by 23, and in CD branch, that is I3 is 25 by 23. This is the response by 5 volt source. Now let's see the response for 1 ampere current source. So for 1 ampere current source, our circuit will be like this. Voltage source becomes short circuit. This is 3 ohm, 1 ampere, 2 ohm, 1 ohm, and 3 ohm. If you see this circuit, in this circuit there is one current source which will provide current in each branch. So the current division we can assume this total 1 ampere current is divided in 3 ohm, that is I4, I5, I6 and I7. So here the circuit points are AB and CD. So we have to calculate the current I4 and current I7 for the circuit solution. So for the calculation of I4, we will take the equivalent of the left side of this circuit, then we will apply current divider rule. So first we take the equivalent, then we will calculate I4 and I5. Then further calculate the value of I7 by current divider rule. So first we make the equivalent. The equivalent will be like this. This is 3 ohm. This is 1 ampere. 2 ohm. This is 3 and 1 in parallel. 3 in parallel with 1 ohm. That is total equivalent resistance, that is 3 by 4 ohm, and total equivalent is 3 by 4 plus 2, that is 11 by 4 ohm. So this total equivalent resistance is 11 by 4 ohm, and this total current is 1 ampere. This current we are assuming I4, this current is I5. So here we can calculate I4 and I5. So the value of I4 is 1 ampere multiplied by opposite resistance, that is 11 by 4, divided by total resistance, that is 11 by 4 plus 3, or you can say this is 11 by 4 divided by 4 3s are 12, 12 plus 11, this is 23. So this value is 11 by 23 ampere. This is the value of I4 which we have to calculate. This is I4. Now calculate I5 for calculation of I7. So I5 is total current 1 ampere multiplied by opposite branch current, opposite branch resistance, that is 3 ohm, divided by total branch resistance, that is 11 by 4 plus 3, this is 3 divided by 23 by 4, that is 12 by 23 ampere. This is current I5. So our current I5 is 12 by 23. So you can see this is 12 by 23 ampere. Current is I5. Now calculate I7 for CD branch. So the value of I7 is 12 by 23 total current multiplied by opposite branch resistance. This total current 12 by 23 divided in 1 ohm and 3 ohm. So we calculate I7 to opposite branch resistance is 1 ohm. 12 by 23 into 1 divided by total branch is 3 plus 1. So this is 4, 4 3s are 12. So this I7 is 3 by 23 ampere. So here we find all the branch current by each source acting alone. Now for the answer we will take the algebraic sum. So first we calculate I. So here you can see the circuit for the calculation of I. I is flowing from A to B. So 5 volt this current is I2, and for 1 ampere this current is I4. Both are flowing from A to B. So the value of I is I2 plus I4. So let's write the current I is equal to I2 plus I4. So our answer is for current I2, let's see the solution. Our I2 is 15 by 23 and I4 is 11 by 23. So 11 15 by 23 plus I4 is 11 by 23. So our answer is for current I, its value is 15 plus 11, that is 26 by 23 ampere. This is our current I. Now calculate the current I dash, current in branch CD. So the current in branch CD, that is current I dash, this I dash is equal to, for 5-volt voltage source, if you see the 5-volt voltage source, its branch current is I3, that is in CD I dash direction, and other branch current is I7 for 1 ampere, that is also in same direction. So it will be the algebraic sum of I3 plus I7. So the I dash will be I3 plus I7. I3 plus I7, and let's see the value of I3 and I7. I3 is 25 by 23 and I7 is 3 by 23. So put the values of I3 and I7. I3 is 25 by 23 and I7 is 3 by 23. So the answer is for I dash, this is 28 by 23. So I dash is 28 by 23 ampere. So this is our answer for I and I dash. Now our basic concept for calculation of this circuit is, you can calculate the second circuit for 1 ampere by nodal analysis. Then we will take nodal analysis steps and get the solution of I4 and I7. But my objective is we have to know the current divider rule in the multiple section of the circuit. So that's why we will use this concept in the circuit. So for the single source circuit, there are many more resistances in the circuit. You can apply this current divider rule and calculate each branch current easily in minimum steps. So for the superposition theorem application, this is our solution for the circuit, where you will see the concept of applying superposition theorem and calculation of this circuit. So in the circuit solution, our key point is for second circuit, that is for 1 ampere current source, to clear the concept of current divider rule in the multiple sections. So for the 1 ampere current source, you can easily use the nodal analysis, which will give the solution for branch AB and CD. But in some problems, you have only one current source and multiple resistances in the different part of circuit, where you can easily calculate by the multiple sections of current divider rule. So this is our concept, and in this circuit I hope you all clear the concept of superposition theorem. Thank you for watching the concept. Please like and subscribe my channel.